We've talked about the normal distribution and the special characteristics of the normal distribution. And one thing that this allows us to do is reference individuals within the distribution. Specifically, how many standard deviations is an individual point from the mean? This has a special name. It's called a z-score. We'll see that letter Z whenever we're talking about normal distributions. So here's the formula for how you calculate a z-score. You take your individual value, see how far away it is from the mean, and then simply divide it by the standard deviation. And this will tell you how many standard deviations am I from the mean. And you can think that if you would look at a normal distribution that's been converted into z-scores, if you're at the mean, you'll be a 0. If you're 1 above or 1 below, you'll be here with most of the points. 68% or most of the points are within 1 standard deviation. And then you'll see 2 and -2 here. And then we said you'll see 3. 99% of the points are within 3 standard deviations. What we can do here now with the normal distribution is take a value. Let's say you are somewhere around here, and you want to say, what's the area to the right of that curve? You can look that up and you can calculate it. So I'll show you, there's a cool applet here. This is called a z-table applet. And this shows a distribution where the mean is 100, standard deviation is 15. And I can say, what's the area to the right of 15? And if you look down in the yellow, you'll see about 15% of the curve is to the right of that. I can change that value. I say, let's say my z-score is 2. Let's say I'm 2 standard deviations above the mean. So 130 relative to the mean. And you see there's our roughly 2.5%. What if I'm 3 standard deviations above the mean? What if my z-score is, what if I could type? What if my z-score is 3? I see very small percent. What if I was exactly at the mean? What percentage of people are above me? Well, in a normal distribution, the mean, the median, the mode are all equal. So if I hit this, it should cover about half the graph. There you go. And 50% of the points are above the mean. So the z-score allows you to just reference an individual person in the normal distribution. And as you get more comfortable, you see what these z-scores relate to in terms of probability or how weird are they. When we take these z-scores and make a graph that looks like this, we can do what's called a standardization. So a standardized score or a standard normal distribution, we take our data and we set it so that the mean is equal to 0 and the standard deviation is equal to 1. And the way we do this is you take each point and you subtract the mean and then you divide by the standard deviation. This says see handout, but you don't need to see the handout. You just need to see the next slide. So here are the BMI data that I collected in part of my ALE, blah, 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 Chinatown Health Fair. And if you look, somewhat of a normal distribution. The mean is 25. Standard deviation is 3.45. If I take each person and say, how far away are they from the mean? And divide it by the standard deviation, I can make a new distribution, which is now standardized. It's standardized so that the mean is 0. The standard deviation is 1. And when I look at it, I can sort of see this person is 2 standard deviations above the mean. This person is 2 standard deviations below the mean. You'll see this idea of standardization all the time, where the distribution is set. So the mean is 0, and then the standard deviation is 1. So the reason why that standardization works is that when we add or subtract the mean from each observation, what we're doing is shifting the mean so that it goes down to 0. But the standard deviation and the variance, the spread of it is essentially unchanged. Then when we divide by the standard deviation, what we see is that that will now become equal to 1. So the standardization brings the mean to 0 and then the standard deviation to 1. And that gives us this standardized distribution.